Hi, I'm Jonathan, and welcome to the next section on defining advanced data policies. We're going to talk about traffic engineering this time. So basically, we're going to talk about how to do quality of service and create a zone-based firewall. This is the first step of two others, so there's actually a little three-section here. Okay, and we're going to talk about some more data policy basics and how to implement those advanced data policies for traffic engineering. So, control policies affect the routing information. This is what we've been looking at over the previous few sections. Data policies, however, look at and potentially modify the actual traffic. So control policies determine what routes you get, and data policies determine what happens to your packets. All right? A good way to distinguish whether a policy is a control policy or data policy is to ask yourself, do I need to look at the actual IP packets to implement this policy? If the answer is yes, the policy must be a data policy. If I have to look in the header of a packet and make some action based on what's in that header, then it's now a data policy. If the answer is no, it's a control policy. Control policies basically are going to change the TLOCs, the routes, next hops, etc. Data policies change packets, so like changing DSCP values, changing type of service, other stuff. So we're going to look at the actual traffic and at parts of the IP packets, such as the source and destination address, ports, protocol numbers, and DSCP values. A centralized data policy acts on an entire VPN and is not interface specific. You can use data policies to enable many services, such as the following. Service chaining, based on traffic characteristics. Remember, service chaining is doing service insertion multiple times. We can do network address translation. We can do traffic policing and counting and shaping. So if you have a committed rate from a provider of, let's say, 20 meg, throwing 200 megs of traffic at them just means that your traffic is going to get dropped. So you're going to want to shape that traffic to meet your provider's SLA so that you don't exceed it. Also transport selection and the traffic engineering, and then QoS classification. So if I see EF traffic, expedited forwarding DSCP traffic, I'm going to put that into a low latency queue, for instance. Because I need to make sure that that voice traffic gets to where it's going without the actual latency. Some service examples could be either a control or a data policy, depending on how the policy is configured. For example, service chaining could be based on the source or destination site or on the destination IP address. In the former case, the policy is a control policy. In the latter case, a data policy. NAT, by the way, network address translation, is always a data policy. Because I'm modifying the IP packet like crazy. I'm changing the IP address, I'm changing ports. The same is going to be true for QoS because I might change the DSCP values. Right? I'm modifying that IP header, therefore it's a data policy. So a data policy is defined in the configuration policies windows of vManage, just like any other. Basically, instead of the other, we're going to a control policy, we're going to select data policy. Okay? And the policy consists of sequence numbers, which you're going to add one at a time, plus a default action. A number of predefined data policies types are available to choose from as shown here. So the application firewall, we'll talk about that in more detail. QoS, which is basically making sure the traffic is mapped to the correct class. Service chaining, dropping in firewalls, load balancers, and identity providers. That's what IDP stands for, if you've never seen it before, is identity provider. Traffic engineering, which is basically policing and shaping, and we can create one of our own from scratch if we choose. So let's talk about an example here. We want to send all traffic to a specific server running some mission critical application through the MPLS transport and send the remaining traffic over the internet transport. Let's say the mission critical application is latency sensitive, or it's we can't accept the levels of drops that we might get on an internet circuit. So we want to send it over a more controlled circuit. All right? So we're going to examine the IP address of the traffic, and if an IP address matches the specific server, we're going to set a specific TLOC color, thus selecting the MPLS transport associated with that color. Okay? And then if that's down, of course, we want to fall back over to the internet circuit, as always. All right? The whole goal here is this. I don't want to create 65 backup routes for different circuits. I want this to happen automatically and seamlessly without me having to configure it. So, as always, we're going to define our groups of interest up here, all right? And we're actually defining the groups of interest over here, all right? So we have a data prefix for DC servers, and clients. And then we have a site list for 1 and 2 and our VPN list of 10. Okay? So we're saying a destination data prefix list is going to be DC servers. So this is the destination. And we have a source of the clients. So we're setting our local, so we're accepting that route. So here's the route coming in. We're accepting it. We're changing the local TLOC list to use the MPLS over here instead of using any other. All right? And then we're setting that next hop to use that TLOC list. Okay? Oh, this is the return traffic here. So we've got clients here going to servers, and we're also using MPLS. And we're also accepting all other traffic as usual, and then we apply the policy. Okay? All right, and that's how we can implement data policies to prefer one circuit over another. Even if we have multiple backups, we're still going to want to make sure that we prioritize those traffic over the circuit with providing the best quality of experience. And generally, MPLS is going to be better than an open internet circuit. And that's the example of how to do that. Thank you for watching, and stay tuned for the next topic.